Hi, Prof. My name is Bryan. I'm from Group B05 and I'm in charge of the hardware subsystem. So, yeah, just a brief problem overview is that the rising aging population in Singapore makes them declining in physical activity. So, we created a game that is beneficial for them. Now, the problem is most games are expensive and hardware are, very non-intuitive and expensive. So that's why we created our own game, which incorporated Fruit Ninja with a two-player system. We'll go into a brief detail further on. So yeah, the game basically has one attacker and one defender. The attacker is mainly to throw bombs. That is functions to distract the defender. And once the defender slices the bomb, it makes them lose a point. Now the defender is functions the same as the usual fruit ninja game, just slicing fruit, get as much point as possible, and the main objective is to avoid the bombs that were sent by the attacker. And another fun power up is that we can use power ups using our finger gestures, which I will get into more detail in the following slides. Yep, so this is just a brief system architecture on how our overall game is going to be. There's the MQTT program, which is the server that connects every single devices connected. But as you can see, top is the visualizer, bottom is the hardware, and the side is the AI. So just what I'm be dealing with is the hardware part for the attacker and defender. Basically, we're publishing data to the server and also subscribing topic from the server to move our actuator. So there's a sensor to server to actuator kind of logic, which I will get into more detail in following slides. Hey, so, as I've mentioned previously, there's the attacker, right? And the attacker only has one device, one handheld component, which is a glove, which is equipped by ESP32 and one IMU on board. So the interface, the communication protocol used is I2C with 50 hertz, meaning that 50 datas are being sent at a time, at 1 second, sorry. Yep. So, and this MPU 6050 is actually configurable on the accelerometer and gyroscope, which I use 8 Gs, and also the gyroscope is 2000 degrees per second. Why this much is because the motion of throwing grenade is a bit fast, so we picked this standard sizing. And the power is 3.7 600 milliamp hour LiPo battery. Okay, so yeah, moving. So this is straightforward. Just want IMU to send data of the bomb throwing movement. Up next is the defender, which is equipped on the left hand. So it's a glove. You equip these whole systems into your hand. Now the sensors that are being used here are 5 IMUs. And as just like the attacker, there are no actuators. Now, the thing is that we use 5 IMUs, right? And the MPU 6500, so this is a different model compared to the MPU 6050, is a newer model. So basically, we uses because sorry, back again. MPU has two addresses, which is 0x68 and 0x69, but we have five different devices. The main problem is that how does two addresses translate to communicating with five different devices? So fortunately, the Arduino has a functionality called two-wire, which is its own hardware buses embedded. So we can switch between buses. So for address 0x60 hexadecimal 68, so 68 and 69, we can switch in one bus, and another bus also switch between 68 and 69. So the basically uh, how do we switch the address is by having the AD0. So if you see the AD0 pin, if it's connected to ground, then the address is 68. If it's connected to VCC, it's 69. So two addresses on each bus, a totaling of four. Now, the thing is, we also need another IMU to be connected. Now, because we do all the buses are occupied, I opted to use SPI, which is a bit similar to I2C, but instead of just SCL and SDA, SPI enables master in slave out master in. I think, yeah. So a bit more wiring, but it gets the job done. So it's still 50 hertz, same accelerometer, same gyroscope prescription. So yeah, it's powered by this same battery also. You can see here the algorithm for the two wires that is Arduino specific. Yep. And this is just the functionality, just a short function on how to initialize, how to read the MPU using the SPI and also the I2C. Quite straightforward. Okay, so moving on, this is basically the heart of the device. I would say it's the sword hilt, or basically a sword to slice the fruit. Same as the previous one, it has one IMU, but it's using the MPU 6050, the older one, is same I2C, 50 hertz, accelerometer is the same, so it basically tracks the motion of the sword slicing. And there are another sensor being used, which is the pause button, a simple button. Yep. I will be explaining this in further detail, but there are other actuators, which is the LED, the buzzer, the vibration motor. LED is powered by GPIO, buzzer PWM, vibration motors by PWM. So why we use PWM? Because we need to control the intensity, how loud the buzzer is, what's the tone, and also the vibration motor is to set how buzzing, how strong the intensity of the buzz is. Yep. I'll be explaining more on this with the following slide, I believe. Yep. Okay, so this is the sensor and actuator loop. So basically, in each hand, there's the sensor, which is the IMU. IMU is the main sensor tracking and everything, sending to the server. Then once it's sent to the server, it's you can these two devices, these two, which is in the same client, which is the Defender, they subscribe to the topic, and once they subscribe to the topic, they they can get the result if the cut was successful or the cut is unsuccessful. If the cut is successful, the LED will turn green. If it's not, it will turn red. Vice versa for the buzzer and the vibration motor. If it's successful, there are different rhythms that are in place. Okay. So the sum of the testing and validation that I use is first I verified the 50 hertz sampling just as a sanity check, and you can see by the microseconds that the message are being actually delivered in average around 20,000 microseconds. So yeah, it's actually 50 hertz. So this is being simulated using the serial monitor because right now it's still in isolation from the MQTT server itself. Yeah. So it's just another actuator and sensor testing using the serial monitor. Everything is being done by the observation of myself. And another is the data collection script. So basically it's just a way so that I can get the 50 hertz put into a TXT file and send it to my teammate. And there's also the power calculation of the ESP32. All in all, it averages around 1.5 hours. The safety considerations I did with proper wiring, insulation, and the use of non-conducting superglue. And also the lipo braid 3 is slid under the ESP32, making it protected. And lastly, just talk about the design changes that I used, that the battery is 600 milliamp hour instead of 500 milliamp hour, and I used a tripod mount instead of doing the 3D printing because I have no experience. And lastly, is that in our original report we use an I2C multiplexer, but I worked it on, and I was unable to get the address, couldn't get the multiplier to connect. Hence, even I ordered a different multiplexer, but it also did not work out. So yeah, that I conclude my presentation, Prof. Thank you very much.